All right, so now we've got two frames. We've got frame A and frame B. And frame B has a point in it. Or I guess K doesn't necessarily belong to any frame, but we're going to say that we know where frame or K is in frame B. Let's just write that down right now. So let's say that it's kind of like this. So we'll say that point K inside of frame B is measured at, we'll say that this is 2 and 7. Let's just say that. All right. So we know that we can't just do a straight up addition of where this is to that because there's at an angle. So, for example, for every increment on the y-axis, this is slightly going to go backwards on the x-axis in A. So we have to do something different here. But let's get some more things together before we start thinking about that problem. So we need to know where B is. Let's do this. The position of B relative to A. Let's say that's. We'll say this is 2 and I don't know, let's say 9. That's where it's at. And then the last real piece of information we need to know is the angle of XB relative to XA. So if you were to bring this right down, what would that angle be? And so let's say in this case, it's, let's say 30 degrees. It's 30 degrees there. So what our standard form is going to be if we're looking for, what we're ultimately looking for is K within reference frame A. So we're looking for this here. We're looking for, in frame A, we're looking for K. So kind of our standard formula here is we're going to have something called a rotation matrix. So that's notated as R with a pre-superscript of A, B. So this is the target frame, and this here is the current frame, or the frame that we're coming from. So we're going to multiply this reference frame by the point BK, or K in frame B. And then, of course, we're going to also have to add our position offset, which in this case I'm just denoting as this. Like I said, this isn't quite the right. Normally we don't have this B here, but I do it just because it makes sense. All right. So what is this rotation matrix? Well, here, let me write down. This is just what I remember, right? There is definitely some math behind it, but we're just going to say, that our rotation matrix looks like this. And it's the cosine of the angle between XB and XA. So it's a cosine of the angle between XB and XA. So it's kind of a shorthand that I'm doing there. This is going to be a 2x2 matrix. So this is the angle between YB and XA. This is the cosine of the angle between XB, the x-axis and B, and YA. And then finally, this is the angle between YB and YA. So let's figure out what this is for our case here. So we've got something like this. So 30 degrees is the angle between XA and XB. So we've got cosine 30 degrees. The angle between XB and YA. So if we were to put this right here, we know that would be 30 degrees, and so 90 minus 30, that's 60. And even though it doesn't matter, I like to put a negative 60 there. What else do we got? Cosine of the angle between YB and XA. So YB and XA. So that's somewhere kind of over here. So that's 90 plus 30, right? Because remember that this is a 90 degree angle. So 90 plus 30, cos of, 120 degrees. And finally, the angle between YB and YA. So once again, that's going to, if you were to move this over on top of this, it would be 30. And we can go ahead and just calculate this out. Move this guy out of the way now. Calculate this out, and it comes out to be 0.87, negative 0.5, 0.5, and 0.87. All right. So now we can go ahead and start carrying out some of these operations here. So what this comes out to be, well, we're going to have a rotation matrix here. So multiplied by our point in frame K plus position of B in A. All right. So to multiply this, this is something that you can, kind of look up if you don't know how to do it, how to multiply a matrix of this dimension by this dimension. So what this comes out to be, well, actually here, I'll write it out. So this comes out to look something like, this is our standard form. We've got A times B, I'll do lowercase here, B, C, D, times an X and a Y. This comes out to be AX plus BY CX plus DY. So let me get out my calculator here. Just a second. Sorry, I should have had that all ready to go, but I don't. All right. So our A is 0.87. So 0.87 times 2 plus, and we've got B, so negative, so I'll do minus 0.5 times 7. So that's, is that right? That can't be right. A times X, so we got a little less. Oh, I might have an order of operations error there. No, I think. Okay, no, I think that's right. Okay. Sorry, I just had something weird happen there. So I'll do it one more time. 0.87 times 2 minus 0.5 times 7. All right, so we'll come down one more step here. So this is negative 1.76. And then we've got 0.5 times 7. So 0.5 times 7 plus 0.87. Oh, shoot. 0.5 times 2. Sorry, 0.5 times 2. So we got 1 plus 0.87 times 7. All right, 7.09. Cool. So now what we can do is we can add our offset there. And so what's that going to come out to be? That's going to be point 0.24. And this comes out to be comes out to be 16 point. Did I do that right? Oh, I know what I did wrong. Sorry, my numbers aren't quite making sense to me here, and I just figured out what I did wrong. So what did I do wrong? Can you see what I did wrong? I can see what I did wrong. Kind of looking at this as a reference, what I did wrong here is these two values need to be switched. Right? This I'm kind of thinking that this is 9 and this is 2. So these need to be switched. So let's just do that real quick. Let's scrub that. Say we've got plus. So we'll correct this right now. We've got a 9 and a 2. So what's this come out to be? Hopefully this will look a little bit more right there. So this is what do we want? 7.24, and then we're gonna have 9.09. And so there's kind of our final point. Let's see if this makes sense here now. So this is 2, 7. And so we'd expect that we should be a little higher than 9, right? If this is 7 up, a little higher than 9 on the y-axis, and that's about right. But we're also going to be going back from this offset, and we're going back enough distance that it brings us to 7.24. So just kind of looking at that does make sense.